Well, as we brought you earlier in the program, a NASA spacecraft has successfully crashed into an asteroid in a world-first defence test. The rocket hit the moon of a larger asteroid at a speed of 22,500 kilometres per hour. The experiment aims to see how the rocket could alter the asteroid's course in deep space if one ever came close enough to Earth. NASA will measure how far the asteroid was thrown off course over the coming weeks. Joining me now live is Logistics Manager for CSIRO NASA Tracking Station, Glen Nagle. Glen, good morning. Thank you for joining us. How would you describe what we witnessed this morning?
Spectacular, wondrous, amazing. Just another incredible moment of space exploration history as this little refrigerator-sized spacecraft smashed into this pyramid-sized asteroid at over 6 kilometres a second, and the images were just beautiful and all brought back to Earth through our incredible antennas here at the Deep Space Tracking Station.
So I'm guessing there was lots of celebrations there this morning as well?
So we have what we call professional excitement. We still have a job to do, but we really were loving watching those last final moments as the spacecraft raced up towards the asteroid. And then, of course, the eruption of joy from the mission science team themselves, all the cheers and hugs and high fives. And that's something that we love to see. That's turning the volume right up to 11.
Absolutely. And there's no doubt that this took a lot of planning. Was there ever any doubt? Could something have gone wrong? Could there have been a miss, or was this always going to go ahead as planned?
There's always that tiny thing in the back of your mind saying, oh, what happens if it misses? And they had backup plans for that, seek out another asteroid. But the targeting cameras worked exactly as they were designed to do. This spacecraft impacted directly into the middle of this little asteroid. I say little, it's the size of a pyramid, 160 metres in size. And it looked like an amazing little rubble pile with house-sized, car-sized boulders strewn across its surface. There's so much that we're going to be learning from this impact today. And it's just so proud that our CSIRO team here in Canberra maintain contact with the spacecraft right through those final hours, right up to the very last moment. And of course, it's not over yet. We still have stuff to come back from the Lycia spacecraft that travelled with the DART spacecraft, which head back safely to watch the impact. So we're anxiously waiting to see what images it returns.
So how long will it take for those images to get back, and then what happens with that data?
So there'll be more data coming back over the next few days, but really from this spacecraft, it's collected so much information, it'll be weeks and months in some cases to get every scrap of data back. But they'll be analysing what they've learned right now, just from the camera on the DART spacecraft itself and from other spacecraft out there that were also watching this event, including the James Webb Space Telescope, being able to see the aftermath of this impact in infrared light to see what heat might have been released.
So I guess it's obviously planned for the rare event of a doomsday incident. Can we take some comfort in that perhaps in the event that something was to happen, Glen, then we might be protected?
Yeah, we want to have a better chance than the dinosaurs had 65 million years ago, of course. And Bruce Willis isn't around to stick on top of a rocket anymore. So this first mission is just one of a whole series of efforts to learn more about asteroids. We're returning samples from other asteroids that we've visited. We've got another mission heading out there from the European Space Agency called Hera, which will go and visit this pair of asteroids that we've collided with today to learn more about what happened afterwards. And of course, the other tests to learn a little bit more about the wealth of objects that are out there in deep space. At the moment, we probably only know about 40% of the total family of objects that could come a little too close for comfort. And so that might not sound particularly comforting to anybody listening, but at the moment, we know for certain that there's nothing coming our way, at least in the next 100 years. So we have plenty of time to find out about the rest of the solar system.
Good to hear, and what a terrific test, a successful test, and more celebrations to be had, no doubt. Glen Nagle, thank you for joining us.